Welcome back to 10.5, day 1. We're now looking at the binomial theorem. And the binomial theorem, to find certain coefficients, to find specific terms, so we don't have to generate this whole list or generate the entire thing to expand this. So with this, what I can do for binomial theorem, the coefficient of the xth term, I probably should have said nth, but I'm not saying nth on purpose. The xth term in a plus bi to the n. The reason I didn't say the nth term is because n is my exponent there. To do that, I'm going to do n is the NCR, which is a combination. You may remember it from Algebra 2. This total quantity, choose this many. So here's what I need. I need n to be the power that's on here, that's on our binomial, and r is going to be the term minus 1. Term that I want minus 1. And if that's the case, then my element will look like the following. The element, the xth term, will look like the following. It will be whatever NCR is, and we'll be able to get that from Pascal's triangle. I'll show you, that's pretty cool, times a to the n minus r times b to the r. All right, so let's take a look at an example of what this means. So let me just explain this a little further before we get into this specific example. You want to find, let's say, the 7th term. Then this, and our exponent is like 9 maybe here. Then our power is 9, so we'd have 9 choose not 7, because r is going to be 7 minus 1. It would be 9 choose 6. 9 choose 6 would be our leading coefficient. I'll show you how to get that from Pascal's triangle. And then we have a to the n minus r. That would be 9 minus 6, so that would be a cubed, and b to the 6th. Let's take a look at this one. We actually have that. What a coincidence. 6th term, 9. So in this case, n equals 9, and r equals, since I want the 6th term, it's going to be 6 minus 1, which is 5. So to find the 6th term, I have to do 9 choose 5, which you can use your calculator for. You don't need to, though, because you're going to already have Pascal's triangle. We're actually going to do 9. I need math. Math for probability, NCR. 9 choose 5. 9 choose 5 is 126. Now we're not done, but we're getting close. Times a, well in this case a is x, times x to the 9 minus 5, which is going to be, 9 minus 5, which is going to be 4, and b to the 5, so y to the 5th. So we have 126, x to the 4th, y to the 5th is what I get for this. Now, I want you to look carefully at Pascal's triangle. We did 9 choose 5, and we're talking about something to the 9th power, or to the 9th row 9. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Where is that number located in row 9? Right here, right? Right there, 126. Notice that's in row 9, right? 9 choose 5. And it's actually, this is the number where it came from. It's this one right here. Because this is column 5. Column 1, 0, 1, 2, 3, 4, 5. Here's column 5. Here's row 9. That number is in Pascal's triangle. I don't even need my calculator to get the number if I have Pascal's triangle already generated like we do on the first page. So when I'm looking at this from Pascal's triangle, I would use the element from row 9, column 5 from Pascal's triangle to get that 126. Or I can use the NCR calculator feature, which again, to do that, and it's not working, there we go. I would do 9, math, go to probability, down to NCR for combinations, choose 5, and I get the value. Try this for letter B. If you did this correctly for letter B, then you had the value of n at 13. And the value of r, since well, actually 13 is a little tricky, because you might not be sure, right? Why does it say 10? There's an error here. N is supposed to be, n is 13, that's right. A sub 10. So that means they did 13 minus r. 13 minus r was 10, which means that r is 3. Which if r is 3, that means that we're actually finding the 4th term. Okay, that's fine. I don't need to know that part, but I know the value of r now. So I also have to make sure I put the negative with the variable b. So I'm going to have 13 choose 3. There's the value of r anyhow right there, 3. 13 choose 3 times a to the 10th negative b to the 3rd. Right? There's the n minus r, there's the r. So 13 choose 3, I don't feel like going to the 13th row of Pascal's triangle. Since I don't already have it generated, I'm just going to do the calculator. 13 choose 3 is 286. And that pen's not working. That's 286. And then this is a to the 10th. And negative b to the negative 3rd will be b to the 3rd, but that means I have to make the whole thing negative, because whatever number is here is going to be multiplied by negative 1. So negative 286, a to the 10th, b to the 3rd. We're going to try this for letter C. This time our a is 2x, our b, that's our a, that's our b includes the negative sign, the negative 3y. We're supposed to find the x to the 3rd, y to the 5th term. Notice our n is 8, our r is 5. So we're going to do 8 choose 5. I can use Pascal's triangle for that. Oops, here we go. There's row 8, column 0, 1, 2, 3, 4, 5. Here's column 5, and row 8 is 56. If you're not confident in that answer, then you can do NCR. And again, you're going to do 8 choose 5, which is 56. But now I have 2x to the 3rd, because that's 8 minus 5, and negative 3y to the 5th. Well, 2 to the 3rd is 8, so that's 8x to the 3rd. And negative 3 to the 5th is going to be negative, but I'm just putting in here anyhow. Negative 243 y to the 5th. So when I multiply this, 56 times 8 times negative 243 is going to give us a negative answer. My final answer is going to be negative 108,864 cubed y to the 5th. So I'm able to find this, the 6th term, right, because r is 5. I'm finding the 6th term when r is 5. So the 6th term is this. I didn't have to generate the entire binomial. I didn't have to expand the whole thing to say what it would be to the 8th power, because they just wanted to know what this term would be, what coefficient would be in front of this term. Take the moment to pause the video and try this for letter D. If you did letter D correctly, let's take a look. You should have 15, which is the value of n. N equals 15. The 11th term, if I want the 11th term, I actually have to do r equals 11 minus 1, so 10. So I need to do 15 choose 10 times 2p to the 15 minus 10 is 5, and 1 to the 10th. Well, 2 to the 5th is 32. So this is 32p to the 5th. 1 to the 10th is just 1, so that's easy. And now I'm going to do my NCR. So I have 15 choose 10, which is 3003. Multiply that by 32, and my final answer is 96,096 p to the 5th. That concludes the notes for today. You actually should be able to, using the binomial theorem, which we're going to write down in a second. We're actually going to write this down, just the generalization of it. You're going to be using this just the way we did before. But basically it says that to use Pascal's triangle, you would just do a plus b to the n. And you don't even need Pascal's triangle necessarily. You would do NC0 for the first term times a to the n, b to the 0, because that would be n minus 0, and that would be r. That would be the first term, plus NC1 for the second term, the one from column 1 of Pascal's triangle, times a to the n minus 1, b to the 1. So there's n minus r and r again. So this is our 0 term, our first term from the row, from row n, plus NC2, a to the n minus 2, b squared. And you would continue this all the way until you got to whatever power you're going. So that would be NCN, a to the 0, b to the n. This should look a lot like what we did before, right? If it was to the 5th, then it's 5, 4, 3, 2, 1, 0 for the first term. And from right to left for the second term, it'd be 5, 4, 3, 2, 1, 0. And this is the starting coefficient. So we've done this. We actually don't need to look at Pascal's triangle. We can actually use this rule to expand the binomial. And in that case, our A is 5m, our B is 4, our N is 3, and then for each element, we'd have 3 minus r. So here we go. This would be 3 choose 0, 5m to the 3rd, 4 to the 0, plus 3 choose 1, 5m squared, 4 to the 1st, plus 3 choose 2, 5m, 3, 2, 1 to the 1st, 4 to the 0, plus, oh wait, this would be 4 squared, sorry, 4 squared. Because if this is 2, then the 2 goes here, 3 minus 2 is 1. Plus 3 choose 3, 5m to the 0, 4 to the 3rd. Now I prefer just to grab these numbers from Pascal's triangle, that's easier for me, but this is using the binomial theorem to expand. And it will generate the exact same answer that you would get if you did this using Pascal's triangle. That concludes today's notes. On day 2, we'll be looking how to represent these using sigma notation. Please give these a try, and we will check them in class. Have a great day.